Hello everyone. In this video, I'm going to discuss the solution for merge two sorted lists, which is third question in the linked list section of 75 LeetCode questions. So let me start sharing my screen. Yeah, so I like to follow these 8 steps. So yeah, for every question. So let's start by the first step, which is reading the question itself. And the question says, given the head of two sorted linked lists, merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay, now, all right. So this is important. The list should be made by splicing together the nodes of the first two lists. Okay, and this basically means that they are asking to just use pointers, because we can always create two arrays and then perform some sort of logic, but yeah, try to use pointers, they suggested. And then, okay, basically in the question what they're saying is they're giving us two lists and we have to return one list with the sorted. Now both lists can be empty, one of them can be empty, or let's say, yeah, both of them have some items. So that's multiple cases. But yeah, looks like 124, 124. Quick observation, duplicates can be present. And so yeah, after looking at this, we see that the input in this question is going to be a pointer and two pointers actually. If say P1 and P2 were P1 is pointing at the head of worst, P2 is the second, and output they want is also a pointer to this one, output. So yeah, we know what input is and output is going to look like. We understood the question. We wrote the test cases, edge cases. Now, yeah, let's look for a brute force solution. So pointers can be complicated if we don't try to understand them clearly. So brute force, I would say, let me think. We can create two vectors, iterate through lists, both the lists, and create two vectors. Let's say list is 1, 2, 5, another is 1, 3, 5. Then you can say 1, 2, 5, 1, 3, 5. And then actually what you can do is, rather than iterating, what you can do is just create one vector. It's a brute force way. That means we are just trying to figure out a solution for it. So you can just create one vector, iterate through list 1, iterate through list 2, put all of them in the back. Let's say we put first items of the first list, then we put second list item, and now we can sort this array, which will take n log n time, and it will become 1, 1, 2, 3, 5, 5. And you can keep n and m as the size of the list, and then you can just create a new linked list and with n plus m nodes, and you can just start filling their values from the vector. So once you create a new list, yeah, once you create a new list, you can just say, all right, put one here, put one here, this becomes here, this becomes 2, 1, 3, 5, and then return the node of head of this list. Now if you see, big of n plus m is the space complexity for this, because we are creating a vector and then plus one list 2. So twice of big of n plus m, which becomes big of n plus m. Time complexity, if you think about it, we'll iterate this through this one, we'll iterate through this twice, and then we are gonna iterate through this again. So big of n plus m is also the time complexity. Now, is there a way for us not using any space and just move the pointers and then sort it out? Actually, there is. So let me discuss the efficient solution. So we looked at brute force, now we look for efficient solution. So let's say the list is like this: 1, 4, 7, 2, 3, and then 5. And this is P1 and this is P2. First, what I'm going to do is create a new node. And let's say we are going to name it as new head. And new head, and I'll also take one current pointer to this. And then I'll start a code execution. What I'm going to do in the code execution is check for P1 and P2 both. And whichever value is less, actually, let me actually do a big one. 1, 4, and 7. 2, 3, 5. So this is originally the list looks like this. And we create a new head, which is this. Now, every time what we'll do is like we'll compare P1 and P2 pointer value, and whichever is minimum, we'll set that to the currents next. So in this case, P1 is smaller than P2. So what you'll do is currents next will point to P1, and then current will come here. And then P1 will go here because P1 was added and P2 will remain here. Now in next iteration, let's see, 2 is smaller. So currents next will become 2, and because P2 is where the pointer came, so we'll move P2 to here. Now if you think about it, this loop just broke when we did that. And then when we made P2 like this, when we made this connection, the next value of this is lost, but P1 is there, so it's good. Now in next iteration, we'll say P1 is smaller, P1 2, it's a P2 is smaller. Then we'll make this connection and then put current here. And because P2 is considered, we will move P2 here. Now current is here, P2 is here, P1 is here. Which one is smaller? P1. So what we are going to do is 0.324, and then P1 will be moved to the next of this, and current will come here. Now the list looks like this. So let me take 1, 2, 3, 4. And now think about it. This loop is just broken because this one is created. So current is here, P1 is here, P2 is here. Now which one is smaller? P2. So we'll make this connection, and then my pencil is giving me issues today. And this will become current, and P2 will become null. So if you think about it, our list just came down to this. Actually it's not good. 1, 2, 3, 4, 5. And now whenever P1 or P2, one of them becomes null, what we're gonna do is check if P1, what happened here is like basically we started creating a new list, but in the end, one of the pointers became null. So what we'll do now is say whichever one is not null, just put currents next to that. So let's say if here in this case the list was not just finishing at 7, it was like 8, 9, and blah blah blah, anything else. So what we're gonna do is if P2 turns out to be null, just set currents next as P1, and that list is already sorted, so we don't need to sort it. So yeah, this looks good. And now another case is both of these goes null at the same time. In that case, we already sorted everything. And if none of them goes to null, then it's good. So yeah, let's look at the code for this. So what we're gonna do is first we create a let's say node is the class node pointer new node, and in the end we'll just return the new nodes next, which is pointing to this one with new node pointer, and then it will be just a new node, and then we create another pointer current which will go through new node. And now what we're going to do is while p1 is not is equals to null and p2 is not equals to null, we'll just go in and say if p1's value is smaller than p2's value, currents next is equals to p1 and currents become currents next, else and p1 becomes p1's next, else currents next is equals to p2 because p2's value is smaller, current becomes p2, p2 becomes p2's next. Now once this is done, we're gonna say if p1 not is equals to null, that means p2 is null because this loop is not being run. So what we're gonna say is just say currents next is equals to p1. Yeah, we're gonna say if p2 is not equals to null, currents next is equals to p2, and the end return new head next. So if we evaluate the time and space complexity, we just create big of one space here. So space complexity is just big of one. And time complexity, if you think about it, we are only iterating it once, so big of n plus m. Actually, let me think about it. Yeah, worst case n plus m, where n is the size of list 1 and n is the size of list 2. So yeah, let me code this solution. Let's take, we can just say new list node. We don't want to give any values. And we're gonna another say list node pointer. This will be current, it will be, and we're gonna say while, let's just name it as p1 and p2, while p1 is not equals to null and if this is true, then what we're going to do is say currents next is equals to p1, current itself becomes p1 and p1's p1. This execution is very important here. Like we cannot change p1 to p1's next before assigning current there. So yeah, as replace everything to p2. And then what we're gonna do is if p1 is not equals to null, not bad, currents next will become p1. Another one we can do is if p2, actually let me, current next becomes p2, and at the end we are gonna just return now. Think about it. If P1 and P2 are both given as null, this will be never executed. This will be never run. And then we return new heads next, which is null pointer. If P1 is null, P2 is not. This will never execute it, this loop, because both of them are not null. And just next will be pointed to P1. And same with P2. And if value is there, then we'll do that. So yeah, looks good to me. Let's run the code. Submit it. All right, beats 85%. So yeah, very efficient solution. Yeah, let me know if you have any comments, but this looks an efficient solution just by using pointers. And thank you, everyone.